Okay, welcome to part 5, year 10. So what we're going to be doing now is we're going to be doing a skill called rationalizing the denominator. Rationalizing the denominator. Now let me explain exactly what that means, okay? Here I've got 4 examples of some fractions involving surds, okay? Now we would have talked about, remember when we did sets and Venn diagrams, we talked about the idea of rational and irrational numbers. And we said we use this notation: Q for a rational number and not Q for an irrational number. And we talked about what rational numbers were. Rational numbers are numbers that can be expressed as a fraction where A and B in the fraction are integers, okay? Irrational numbers cannot be expressed as a fraction. So I gave some examples of that. For example, pi is an irrational number. Also root 2. So actually, surds are irrational, okay? Except, well, let's just do some more. So root 3, that's irrational. Root 4 is not. That is rational. Why? Because root 4 is 2. And 2 can be expressed as a fraction, 2 over 1, where both the numbers are integers. Root 5 is irrational. Root 6 is irrational. Root 7 is irrational. Root 8 is irrational. But root 9 is 3, which can be expressed as a fraction. So root 9 isn't. What you'll notice is all of the surds where the number underneath is a square number are rational, but all the numbers where the number underneath is not a square number are irrational. That is to say, if you put them in a calculator and work out what their decimal version is, they will go on and on and on forever and ever and ever with no pattern. Okay? So most surds, except the square number surds, are irrational. Now, so that hopefully explains what we mean by rational and irrational. Let me just delete that now. Now, what we've got here, let's look at number 1. Just label these in 1, 2, 3, 4. Number 1 has a irrational number in the denominator. Okay, root 2 is in the denominator and it's irrational. Now, for some reason, and I suppose there are good reasons for this, we don't allow an irrational number to be in the denominator of a fraction. We can allow it to be in the numerator. So if I wrote root 2 over 17, the reciprocal of 17 over root 2, that would be fine. I wouldn't need to change that because my denominator is rational. Okay, but in the question I'm actually being asked, the denominator is irrational. So I have to rationalize it. Okay, I have to turn the denominator into a rational number. In doing so, I will turn the numerator into an irrational number. Okay? So let's just have a look at how I do it. So 17 over root 2. What I'm going to do is I'm going to times the top and the bottom by root 2. So basically, whatever is in the denominator, I'm going to times top and bottom. Now, just think very carefully about what's going on there. What is the value of this? Root 2 divided by root 2 is equal to 1. So what I'm really doing is I'm doing 17 root 2 times 1. And if I times anything by 1, the value of it doesn't change. Okay, so I haven't changed the value of my surd at all. Okay, of my fraction. I have not changed the value of it because I'm timesing it by 1. But I am going to change what it looks like. Okay, so I'm going to end up with 17 root 2 over 2. Okay, and now I've done what I said. I've turned the denominator from being irrational number into a rational number. It's now 2. The denominator is now 2. And that's what I wanted to do. As I said, in the process, I turned the numerator into an irrational number, but that's okay. That's what we want. Okay, so the answer is 17 root 2 over 2. Now, let's just look at number 2. Again, what I'm going to do to rationalise number 2, I multiply top and bottom by what the denominator is, except I don't need to do the 7. I can if I want, but I don't need to. All I need to do is multiply top and bottom by root 5, okay? So multiply top and bottom by whatever surd is in the denominator. And I'm going to end up with 3 root 5 on the top. And on the bottom, root 5 times root 5 is 5, and then times 7 is 35. Okay? So 3 root 5 over 35 is the answer to number 2. Okay? What about number 3? Well, actually both the denominator and the numerator are irrational here, but that's okay. The same process will apply. Let me just write it over here. Root 22 over root 3. What I'm going to do is I'm going to times top and bottom so that it's still, don't change the value of it because I'm just timesing it by 1. Whoops. I'm going to get root 66, that's 3 times 22, over 3. Now what you need to do is you need to check whether you can simplify the surd that is in the numerator. 66. Well, 66 is 6 times 11. 11 is prime. 3, 2. I've no pairs there. I've no pairs in my prime factor decomposition. So 66 has no square factors. So actually it can't be simplified. So that is my answer. Okay, it's root 66 over 3. Okay? Right, what about number 4? Let's just clear some space for a second. Now, number 4, again, what I'm going to do is I'm going to times top and bottom by root 3. By root 3. Top and bottom by root 3. So I need to times 1 plus root 3 by root 3 and 4 root 3 by root 3. And to do the numerator, I must use a bracket. So root 3 times 1 plus root 3, just the same as algebra. Okay, divided by 4 root 3 times root 3. Well, root 3 times root 3 is 3, 4 times 3 is 12. Okay, and now I can expand the bracket if I want to. Root 3 plus 3 over 12 is my final answer. Okay, that's as simple as we can make it because you can't simplify root 3. Okay, so in each of these, all I've done is I've had an irrational number in the denominator, but in my answer, I've got a rational number. Okay, irrational number turns into a rational number in the denominator. Oops. Okay, irrational number turns into a rational number in the denominator. And same again, last one, an irrational number turns to a rational number in the denominator. So I have rationalised the denominator. Okay, hope that makes sense. So here are 6 questions for you to have a go at. Stop your video, have a go, and I'll reveal the answers. Okay, hopefully you've done that. Here they are. Okay, any doubts about them, just let me know. Any problems, just ask me. Okay. Right, okay, I'm going to stop the video there and we'll come back for the last part.